Oh, hi. This is the Mathization channel on YouTube. This is just a derivation of the area of a circle or disc. Circumference C is circumference, D is diameter, equals twice the radius right here. And R is diameter divided by 2, the radius. And we know that circumference of a circle is 2 pi r. Pi is about 3.14. And so times 2 is like 6.28 times r. Actually, that's also equal to 2r is the diameter, so it's the pi times diameter. So it's like 3.14 times longer than the diameter. And an extra note here is if you were to solve for pi here, it's circumference divided by diameter. For any circle, it's always equal to pi 3.14. It's about equal to 3.14. Okay. And it got a bunch of other digits. It's a irrational number. It just keeps going and going. It doesn't repeat. Okay. There's no specific value for it. It's an endless value. So we just use the most significant digits that mean the most. Okay. So what's the area? So if you were to take this half the circumference, or like of the upper hemisphere here of the circle or semisphere, and okay, and you were to straighten it out, like hold it here and then pick it up like there, and over here there, it will come out, be like this shape here, and you see that the diameter here is less than that, half the circumference. Okay, and so just take this area here, you'll get this half the circumference times the radius, and clearly that's more than the upper part here of the circle, the upper hemisphere. See, it's much more. So you can't use half the circumference times r as is. Let's see. Yeah, because if you did that for the bottom area too, you would be like way more than the area of the circle. Okay, so what happens is when you open that up for a just a straight length, half the circumference, you introduce gaps here. This radius value can be thought of as like a very thin rectangular area. Okay, and then when you consider the bottom, it's going to put gaps in that too. And if you slide them together, you'll get this. You'll just get a solid upper, one solid that is half the circumference. Wait, half the circumference times the radius. Okay, so you get a solid rectangle that does equal the area of the circle. So the area of that rectangle is base times width. This is the base and the width. Half the circumference times r, and or half the circumference times d divided by 2, and that's circumference times diameter divided by 4. That's an alternate formula. The area of the rectangle is now 2 pi r divided by 2 times r, and if you can, these 2's in the numerator and denominator will cancel out to 1, and you're left with pi r squared. and that's the area of a circle, of that circle, equal to it. So I know there's another formula. It's an easier one, I guess. It's the circumference times the radius. You have a triangle like that. Okay, that's because when you can take you take a circle, you unroll it, you'll get that. So if you were to roll this up, it would be a circle. This is the radius in that circle. So and then the area of a triangle is base times height times radius divided by 2, and you get the same value. Be the area of the circle is pi r squared. You get the same values down here, right there. Circumference, half the circumference times the radius. You get the same value. So that's a yeah. Actually, that's based on like this. Yeah, that's the center of the circle right here, right? And if you and that's the circumference, and then if you were to take that length and then this length and then this length, this length all the way around, you would get this here. Okay, circumference and triangle like that, and you can line them to the right. There's some rule that it's equivalent. I don't know right now. The Cavaleri's theorem or something. Okay, yes, and you would get that right triangle. That's equal to the radius r. So that's the most popular formula there. But this is another one. I think some people might indicate it, but they don't explain it how you get that. Okay. Okay, thank you.